let's calculate the closed formula of the Fibonacci sequence recursive relation is that general term is equal to the sum of the previous two terms. And first two terms are both 1. And so to rewrite this recursive relation, an minus 1 minus an minus 2 is equal to 0. Also, I'm going to construct a function f of x, infinite sum. N goes from 0 to infinity, an times x to the power of n. This an is the same as this an. This is a generating function. So multiply by negative x, f of x. That is equal to negative infinite sum. N goes from 0 to infinity. An times x to the n plus 1. Negative x squared times f of x. That is equal to negative infinite sum. N goes from 0 to infinity. An times x to the n plus 2. This time I'm going to isolate the first two terms out of here. So I just start from 2. Right? Start from 2. So first two terms, a naught times x to the power 0, that is just 1. Second term, n equals 1, a1 times x, that is just x. Right? So isolated it out. So this infinite sum, I'm going to replace n with n minus 1. Right? So an become an minus 1. N plus 1 becomes n. Right? And also change the starting point. When it was an, I start from 0. Now it's an minus 1, I start from 1. Likewise, when it was n plus 1, I started from 0. Power starts from 1. The same thing. Right? So if I isolate the first term, I start from 2 this time. What's the first term? There's a negative sign. First term, n equals 1, a naught times x, just x, right? Minus x. Right? So this is good. Also, replace n with n minus 2. Right? The n minus 2. N plus 2 becomes just n. And also, when it was n, I start from 0. Now it's n minus 2, I start from 2. It's a dummy index. Right? Dummy index, that's fine. When it was n plus 2, right? N starts from 0. Power starts from 2. Power starts from 2. Exactly the same thing. So I don't need to isolate anything out of here. All I have to do is to add them all up. This, add them all up. Common factor, f of x. So bracket 1 minus x squared, f of x, equals exactly isolated term, 1, x minus x, that's gone. It's 1. And also I have exactly the sum of exactly same starting point. Right? Start from 2 to infinity. Common factor, I have x to the power of n, right? Bracket. I have an to begin with, minus an minus 1. Minus an minus 2. X to the n, right? So this part, right, already 0. That's rewritten the recursive relation, right? So this is gone. So f of x is equal to 1 over 1 minus x squared. All right, we're going to separate this fraction into partial fraction. Now, if I just look at this quadratic equation, minus x squared minus x plus 1 equal to 0. Right? So this is the denominator, right? So first root, negative 2, 1 plus, the other one is minus square root of 5. I distribute the negative sign. Negative, negative. Second root, likewise, negative 2. 1. Previous was plus, now it's minus. Minus square root of 5. Same thing. Distribute the negative sign. Negative plus. These are my two roots. So this time I can rewrite f of x into partial fraction. F of x supposed to be 1 over. First, I'll take out the negative sign in front of x squared. Negative sign in front of x squared. Then I have the factorization. X minus r1, x minus r2. Right? Positive x. There's negative sign. Right? So same thing. Yeah. So if that's the case, can I just rewrite it into some number multiplied by 1 over x minus r1 minus 1 over x minus r2? Right? Because that way I have, on top, I have x minus r2 minus x. X is gone, plus r1. r1 minus r2 on the top. So multiply by 1 over, not r1 minus r2, but r2 minus r1 because of a negative sign, right? So this is equal to that. So r2 minus r1, right? What is that? r2 minus r1, square root of 5. What is r1 times r2, right? Product of the two roots, that is c over a, c of negative 1. And also rewrite this term, 1 over x minus r1, that is equal to 1 over negative 1. Take out the negative sign out here. So r1 factored out, 1 minus x over r1. Right, that's the same thing. So negative 1 over r1. And so this is a geometric series. Right, x over r1 is the common ratio. I imagine 1 over 1 minus x over r1, right, the common ratio. So infinite sum. And 0 to infinity. Common ratio x over r1 to the n. So likewise, 1 over x minus r2 equal the similar thing. Negative 1 over r2. Infinite sum and of 0 to infinity of x over r2 to the n. And so that now I can just rewrite this term together with this term, right? So f of x this time should be equal to 1 over r2 minus r1 square root of 5 times bracket this term minus that term. So this term minus that sum. Right? This becomes positive. So 1 over r2 infinite sum and 0 to infinity. X over r2 0. This still negative. Minus 1 over r1 infinite sum and of 0 to infinity. X over r1 to the n. And so how can I relate this to this function, right? To f of x, right? F of x to the power n, right? Relate an to this, right? As long as I factor out x to the power of n, so x to the power of n, distribute the power n and put this r2 into here, so the power of n plus 1, right? Also, this becomes distribute the power, right, to the x to the n, r1 to the n plus 1, and this is gone. Right? So factor out the combine the infinite sum. So first of all, imagine I haven't isolated, so I started from 0, right? So f of x. So that way I have infinite sum, n goes from 0 to put the 1 over square root of 5 inside. 1 over square root of 5. X to the n, factor it out. After I factor out the x to the n, I have 1 over r2 to the n plus 1 minus 1 over r1 n plus 1. Common denominator is r1, r2 combined together, raised to the n plus 1, and on the top that is r1 n plus 1 minus r2 to the n plus 1 together times x to the n. Right, so this whole part is an. Now we can just write down an in detail. Now, the an is in fact 1 over square root of 5. First of all, r1 times r2. r1 times r2, negative 1. Negative 1 to the power n plus 1. And r1, r2 are known to be the roots, right? We just worked that roots of the quadratic. So 1 over negative 1 to the power of n plus 1 multiplied by bracket r1 to the n plus 1. r1 to the negative 1 minus the negative power to n plus 1 minus r2 half of negative 1 plus square root of 5 to the n plus 1. But I can somehow factor out the, here I have -1. Right, factor out -1 out here, but -1, n plus 1 distribute to -1. Right, that's the power. So this power distribute to this -1. -1 factor out. So I can still rewrite it 1 over square root of 5. 1 over -1 to n plus 1. Like I said, again, I factor out the -1 to the n plus 1 right, out of here. So here negative is gone, right? It becomes positive. And also this is gone, right? Right? So half, positive, square root of 5. Altogether, power of n plus 1, right? So minus half of negative becomes positive, becomes negative, right? To power altogether to power n plus 1 still. Right? So that's the closed formula. 1 over square root of times the whole thing. Right? So even though it's amazing that somehow we can express a natural number. Right? They're all natural numbers. In an expression that involves irrational numbers.